Okay, Math 3 students in third period, here's a quick video to help finish up the 3.5 task. If you expanded out those functions right there, you should have gotten these polynomials. And then if you looked at the pattern, you can see those are the patterns of the coefficients. But the end of the pattern in here is, where do I find the 3? Well, it's kind of a triangle shape. You add the two coefficients above it. 2 plus 1 is 3. Okay, the 1s are always on the outside. So if you go down to the next line, 3 plus 1 is 4, 3 plus 3 is 6, and then go down to the next line. Okay, so why don't you guys substitute, pause the video for like a minute, let them see if they can get x plus 1 quantity to the 6th. Okay, and it should look like this right here. Don't worry about the x plus 1 to the n. So this would be your binomial expansion out to x plus 1 to the 6th power. Okay, I already spoiled it for you. The pattern is the triangle shape. You add the ones above. Okay, now I'm going to skip over number 12 on the screen right here to show you number 13 first. How do the coefficients change for x plus y? And I did a demonstration on the board. Let's see if I can do the demonstration right now. Well, if you did x plus 1, x plus y quantity cubed, the coefficients would be the same as it was above in the task, but you'd have x cubed, but you'd have plus 3 x squared and y. The other term right here appears. And then check this out. You'd have plus 3, and then you have x. That goes down to a single power, and then y squared. And then the last one would be plus 1 y cubed. So it appears that if there's a number here, it shows up in the expansion as well. Look how x starts at the third power and goes 3, 2, 1. And if this is x to the 0 because there's a 1 right there, right? But the other term starts at 0 power, y to the 0, y to the first, y squared, y cubed. Okay? So if you can follow that pattern, maybe you guys can, let me see if I can set this up without giving away the answer. Do x plus 1, x plus 2 quantity to the 4th power. Try that for a couple minutes. Pause, please. Alright, if you did this out, the first thing you should have done is write this out very slowly and systematically. Let me zoom in a little bit on this. Okay. Again, we take each term, so we start with the x to the 4th. The coefficients 1, 4, 6, 4, 1, that's always going to be there. We'll use that to simplify later. But it's x to the 4th, x cubed, x squared, x to the 1, and x to the 0. And the same thing goes opposite for the 2 term. So 2 to the 4th, 3, 2, 1, and 0. Now we have to use just simplifying to do the arithmetic and the multiplying to get down to that answer right there. 4 times 2 is 8. 2 squared is 4 times 6 is 24. 2 to the cube is 8 times 4 is 32. And 2 to the 4th power is 16. Okay? So that's the ending part of the task. I want to show you the vault notes real quick because you haven't seen them. I don't think. This is really fast. You need to see the fundamental theorem of algebra in the graphs. Always know what a multiplicity looks like. The number of roots always matches the highest degree term. On the ready problems, let me show you those ready problems again. These are very, very in detail, talking about these functions and listing off all of these features. This is a very, very tough part of the homework. Work really hard on this. Okay? The set problem, these are exactly like the task we did and the ready problems together. So like on this one, tell you everything you know, all the features of the function, including end behavior, and also graph it. So this is a really all-encompassing homework. Okay, the last part on the Go problems there, I say use Desmos as a tool to help you graph these and answer these comparison functions you see on the last part. Okay, that's it for 3.5.